One of the most important and useful characteristics of light is that it usually travels in straight lines. Since no one knows exactly what light is, ray optics is a simple way of describing light in terms of its straight line characteristic. A single ray is a line that runs straight out from the source. When many rays are bundled together, they form a three-dimensional beam, such as that produced by a spotlight or a flashlight. A beam is a bundle of rays. In this program, we're going to explore two methods of changing the direction and shape of a beam of light. One by bouncing it off a shiny surface, the other by passing it through a material like glass. In both cases, the shape of the materials determines where the light will go and what shape the beam will assume. A ray of light is like a stream of very tiny billiard balls that usually travel in straight lines, unless they run into something. Where they go after hitting a surface depends on their angle and the shape of the surface. This is reflection. Any good pool player knows the importance of angles when setting up a bank shot. The angle of the ball on the way into the side will determine its angle on the way out. Light rays follow the same principle when reflecting off a flat mirror, sometimes called a plane mirror. The light rays approach the mirror at a certain angle, called the angle of incidence. The outgoing ray will leave the mirror at a certain angle, called the angle of reflection. The nice thing about plane mirrors is that these two angles are always the same. So no matter what angle a ray hits the mirror, the reflected ray will have exactly the same angle. Plane mirrors are used when you want to change the direction of a beam of light without changing the shape of the beam. When you take plane mirrors and bend them, you can do neat things with light. It would be like curving the sides of a pool table. This is the kind of table some of us less skilled players would like to use. Every shot is a sinker. When the balls hit the sides, they always pass over a single spot. If a pocket is located at that spot, you can't lose. If the sides of the table are made shiny, a beam of light will reflect off the sides and also pass over that same spot. Mirrors that curve toward the incoming light are called concave mirrors. If a single ray of light travels straight into the center of the mirror, it will reflect straight back out. This is the optical axis. Parallel rays of light, or a beam, reflecting off a concave mirror will all be directed to a single spot, the focal point. The distance between the focal point and the mirror is the focal length. Finding the focal length of a concave mirror is easy. All you have to do is look straight into it. Then pull the mirror back, and you'll notice that the image will become inverted. Now, if you pull it back again and find that spot where the transition happens, where the image completely fills the mirror, that is the focal point of the mirror. And the distance between your eye and the surface of the mirror is the focal length. Concave mirrors change the shape of a light beam to make images, like those formed by the mirror of a telescope. Or they can concentrate light onto a spot where it can be turned into heat energy like a solar energy converter. Concave mirrors can also work in the other direction. Instead of focusing parallel rays onto a point, a source of light located at the focal point will have its rays reflected by the mirror into a nearly parallel beam. This is the principle behind spotlights, which focus the light to a spot downrange. Sometimes it's necessary to spread light out rather than focus it onto a point. This can be done by curving a mirror outward, a convex mirror. There's no focal point in front of the mirror because the light rays are scattered. But if you find the focal point of its backside, the concave part, then project those lines through the mirror. That's the path the rays will follow when bouncing off the convex side. Convex mirrors tend to produce a slightly distorted image, but their advantage is that they provide a wide-angle view, very handy for watchful store owners. Mirrors shape beams of light and fold light back on itself by reflection. In some cases, you want to shape a beam of light, but keep it going in a forward direction. This is done by refraction, changing the shape of a beam by passing light through a substance. Refraction is something like driving a vehicle off the road onto a soft shoulder, an effect that often catches a driver by surprise. The vehicle tends to change direction when the wheels travel from one medium, the pavement, onto another medium, the gravel. The change in direction is because the wheels on the gravel slow down, while those on the road do not, so the vehicle turns toward the shoulder. When a beam of light passes from one medium like air into another like glass, it actually changes speed. If the beam is at an angle, part of the beam will slow down before the rest, causing a change in direction. The amount of bending depends on the index of refraction, which varies with the type of material. The shape of the material will also affect the path of the light. A triangle will bend light like this. Two triangles will bend rays so they converge at a point. Does this look familiar? By shaping transparent materials, you can accomplish a similar effect as a concave mirror. Focus light rays to a point. It's still called a focal point. Lenses that direct rays to a point are called converging lenses. Lenses that spread light rays out are called diverging lenses. Like mirrors, lenses shape light, except they shape it in a forward direction rather than reflecting it back. And since the light is passing through the lens, there are two surfaces to work with. Changing one or both surfaces will affect the shape of the beam. These two methods of shaping light, reflection and refraction, are the two foundations of optical systems. Often both methods are used in combination to attain a desired effect. A spotlight has its lamp at the focal point of a concave mirror, which makes the beam. Then a lens on the front of the unit focuses the beam onto a small or wide spot at the stage. Many cameras use several lenses, a mirror and a prism to make an image on film. Knowing the effect that mirrors and lenses have on light give the technician an extra tool when using or troubleshooting an optical system.